Great. Yeah, thanks very much, Tom, for hosting this, and thanks everyone for the invitation. Thanks to the center. Yeah, this talk was supposed to happen more than a year ago, and in fact, I never made it to San Diego in March 2020, right? Unfortunately, and you all know why that is. So I'm very glad that we were able finally to pull this off and to schedule this talk. And now it's one of those experiences that all of us make every day. To be communicating around the world in Zoom talks and video conferences. It's become a kind of everyday routine, but we're making use of this. But while I would have loved to be in San Diego and hang out with all of you, it's, yeah, this way, at least I don't have a really bad jet lag. Okay, the margins of predictability, conflict forecasting in a real world. Let me just briefly motivate the topic a little bit. Yeah, it was about 20 years ago when I started out as a master's student in computer science, engaging in machine learning. In machine learning, I went to New Zealand to do my master's research there for a year. And as you know, New Zealand has like lots of, it's very beautiful, but one thing that is cultivated there is kiwi fruit. So kiwi fruit is prominent in New Zealand. There's industrial production, lots of it gets exported. And one of my tasks that I tried my machine learning algorithms with was the classification of kiwi fruits. Basically, the idea was you run the kiwi fruits through a machine, kind of a fast camera, and from the picture, from the properties of the fruit, you would determine if the kiwi fruit was ready to be exported. So it was a machine learning task to quickly automatically classify whether kiwi fruits satisfy certain quality criteria. So this is what I tried there. So in my talk, I will always be coming back to this classification task of kiwi fruit, and it will contrast this with the forecasting, the prediction of political violence and political conflict, right? So overall, you may first think that these are the classification of kiwi fruit and the forecasting of political violence are sort of similar prediction tasks, right? So you're given a set of characteristics of the kiwi fruits or particular countries and political systems on the other hand, and you're supposed to come up with a prediction whether kiwi fruit task, the kiwi is ready to be exported, or in the conflict prediction task, whether there's a high risk of the country experiencing conflict, right? What is the likely outcome? And the approach we go about doing this in the machine learning world is that we examine a bunch of instances. Well, that means kiwi fruit or countries, and then the machine or the computer learns how particular factors that characterize the kiwi fruit or the countries map into the outcomes we're interested in, right? Those could be kiwi fruit quality or conflict outcomes. Does conflict really emerge, right? And so this particular application that I will contrast to kiwi fruit classification is the prediction of onset of civil war in a particular country in a particular year from a set of political, economic, demographic, or geographic factors. And many of you know the literature and you know roughly what I'm talking about. The particular factors today are not of particular interest. We want to take a general look at the complexity of this prediction task overall, right? So my talk overall will be an outside perspective on conflict prediction, right? I will try to characterize in general the patterns that lead to conflict. On an abstract level, what do these patterns look like? What types of combinations of stuff do we need to look at in order to be able to predict conflict in the end, right? So if the task or the conflict patterns, the potentially dangerous combinations of stuff, what does it mean? What does it mean for the data required to detect these dangerous configurations? What is the amount and the complexity of the data that we need for this? And finally, given that we've taken a rather skeptical look, I should say, at conflict, at the feasibility of conflict prediction overall, in the end, I will try to propose some avenues that we can likely pursue if we want to make progress in conflict forecasting. What particular avenues should we follow? So this is a totally bird's eye view, right? So there will be no models, no data, and no results. Yeah, sorry to break the news. This is a very abstract characterization of what conflict prediction looks like and how complex it really is. Right. Let's go back to the kiwi fruit first, right? So kiwi fruit quality in general, and here I'm speaking as an sort of an outsider. The only thing I had to do with conflict with kiwi fruit prediction is 20 years ago. Lots have changed. I think kiwi fruit quality prediction is probably much better now than it is, much more complex than what I'm depicting it now. I'm using this sort of as to contrast or to show you basically the complexity of conflict prediction on the one hand, and kiwi fruit prediction, which is super simple, something totally opposite end of the same difficulty dimension when it comes to prediction, right? So kiwi fruit quality can be assessed by analyzing individual factors of kiwi fruit, right? So how heavy are they? What is the color, and what's the shape of a particular kiwi fruit? And they vary tremendously. Some of them cannot be exported because of that. So what you do is you can automatically measure all these features, and then you basically say if any of these features, a single one, is outside the acceptable range, then you predict poor quality. That's it, right? It's a super simple prediction task. You look at each of these factors in isolation. You can look at weight, then you look at color, and you look at the shape. Yeah, possibly others. What matters here is that you can look at one of these at a time, right? This is very difficult for conflict prediction. Conflict, political violence, obviously, given the tremendous complexity of societies in general, and conflict is a societal phenomenon, of course, right? Conflict happens if a lot of stuff in a society, in a polity, occurs together, right? Here, this is just an illustration, right? In reality, it's going to look much more complex. If a country has poor economic performance and a weak government, and just recently became a democracy, and if there's conflict nearby, if a lot of bad things happen together, then we are likely to see conflict. This is typically what we are interested in, or the underlying predictive patterns, combinations look like, right? A lot of stuff occurring in conjunction. If this happens, if this occurs, then we see a conflict. So if we introduce a little bit of a more abstract notation, it's not going to be much. It's not going to get much more complex than this. So don't be afraid here. I promised no tech stuff, and this is basically where I'm going to leave it. So what if you characterize the predictive patterns that, on the one hand, predict poor kiwi fruit quality, and the ones that predict conflict? This is what they look like, right? So we can formulate these predictive patterns as a minimal logical conjunction of conditions for conflict or kiwi fruit quality. So A, B, C, D, these capital letters are these conditions, right? In the kiwi fruit prediction task or in the conflict prediction task. If kiwi fruit prediction is very simple, we can, a predictive pattern for poor kiwi fruit quality would be just the occurrence of one thing. For example, the wrong shape of a kiwi fruit, right? Says, okay, you can't export it. Yeah? Or if the weight is too high, too low, it's also not ready to be exported. Here, so these are potential predictive patterns for poor kiwi fruit quality. Yeah, predictive patterns for conflict look a lot more complex, right? And here, if I write these capital letters in a sequence, this means there's a logical conjunction. This is a typical Boolean logic notation, right? If this is basically an and in all between all these conditions here. This means A and B and C and D, this first one, right? So this could be one pattern. We don't care what A, B, C, and D are mean in the real world, right? What matters here is that a lot of stuff has to happen together for conflict to occur, right? A, B, C, and D, or B, C, D, E, F, and G, and so on. Or maybe E here, that's the negation. This overline kind of thing is the negation, not E, and F, and G, and so on, right? You get the idea. So these two look really, really different in terms of a complexity of what I call the predictive pattern, or some people call a causal recipe. I'm using these terms here interchangeably. They're combinations of stuff that predict a certain outcome we're interested in. Yeah. So predictive patterns for conflict. Again, some of these conditions only work in conjunction with each other, right? For example, mountainous terrain has come up. It's now more than almost 2 decades ago. For example, Fearon and Layton's work on conflict, on civil war. Mountainous terrain supposedly has increases the risk of civil war, but mountainous terrain, I mean, there's no theoretical reason that mountains alone should somehow drive conflict. Maybe they even don't, right? They predict the absence of conflict. But mountainous terrain, together with ethnic exclusion, may provide sort of a combination of risk factors that could lead to conflict. Yeah, because here ethnic exclusion, you have grievance, and then mountainous terrain provides an opportunity for rebels to hide out that could lead to conflict. But maybe mountainous terrain alone, without a lot of stuff, predicts the absence of conflict. Well, Switzerland, just next door here, I'm just north of the border. Switzerland is 2 kilometers further south. Just mountainous terrain predict the absence of conflict. Yeah, as for example in Switzerland, right? So some of these conditions only work. Mountainous terrain is one of our conditions, with capital A or whatever, right? It works only if we combine it with something else, which means by definition, looking at mountainous terrain alone, it's not going to help us, right? Because it may not be predictive of conflict one way or the other. And sometimes, which makes another thing that makes this prediction task even also more complex, that sometimes the presence and sometimes the absence of a factor is part of one of these causal recipes that lead to conflict. Yeah, democracy and a strong economy probably lead to peace, like conflict negated here, right? But democracy and a weak economy could lead to conflict, right? So this is theoretically perfectly feasible, but this happens again, right? You cannot just draw any conclusions about democracy in isolation. You need to examine this particular condition together with something else, and this generates these predictive patterns, these causal recipes that are that at the end explain or predict conflict. So if we look at basically, if we contrast these two different types of predictive patterns in kiwi fruit prediction and in conflict prediction, here's a set of things where they differ. What is the size of the universe of conditions? What factors, or how many factors, do we need to make a good prediction about kiwi fruit quality? Well, this is just a handful. You look at the shape, or you look at the weight, and maybe 2 or 3 others, you're good, right? For conflict, you need to look at a lot more stuff, right? Features of the political system, history of the country, involvement of or presence of particular minority groups, for example, in a country, could be predictive of conflict, right? So there's a long, long list of stuff that you need to look at when you want to predict conflict. How long is one of these combinations, right? The sequences of letters that I have, these conjunctions of stuff. In kiwi fruit, this is very short. Yeah, one predictive pattern could be just looking at a single conditions, and you can draw a conclusion right away. It's very short. For conflict, the patterns are very long. You need to look at this and this and this and this and this in combination. Otherwise, you can't say anything about conflict, right? Rather long causal recipes. How many patterns are there? Well, if you assume that each of these factors in kiwi fruit prediction is sort of independent of the others, you can just say, okay, we have n possible patterns. Each of the conditions that you're looking at alone is a causal pattern, and that's it. Yeah. For conflicts, there's a lot more. If you assume you have n factors or conditions you're looking at, each of these factors can either be present or absent. It can be like negated or non-negated, like is the presence or the absence can be predictive, or the condition may not be part of a causal recipe at all. Yeah. So this grows exponentially in the universe of conditions that you're looking at in terms of for conflict prediction, right? So the causal recipes that exist, the causal recipes that you choose from, there are a lot more, right? For computer scientists or for anyone else here, exponential growth. Oh, that's probably one of the key learnings we've taken away from the key mathematical learnings from the Corona pandemic. Is people are now much more used to what really exponential growth means, right? And this is dangerous, not just in terms of Corona, but also in conflict prediction, because the complexity of the prediction task gets so much worse. Okay, now how do we go about finding predictive patterns? Ultimately, we're interested in having a set of predictive patterns that map onto conflict, right? Those are sort of our prediction models, if you will. Yeah. So assume we have a theory about the list or about the candidate factors for predictive pattern. Yeah. So we know, okay, these are the things we should look at for kiwi fruit prediction, or for conflict prediction. There's a bunch of things we should look at. We draw a long list. So let's assume we have that. What do we do, right? For kiwi fruit, for conflict prediction, we don't really know what factors we need to include, right? We don't know if the presence of a factor of democracy is part of a causal recipe of a predictive pattern, or the absence of democracy is part of that particular conflict predictive pattern, right? And again, and that's something I'm bracketing out for now, we don't know how many of these patterns exist at all, right? We're totally proceeding in inductive fashion, since trying to learn from the data what predictive patterns there are, right? And as unlike in kiwi fruit quality prediction, if you observe conflict for one particular condition, yeah, is not enough. Yeah, we need to test also whether conflict also occurs in the absence of that condition, or if this condition only triggers conflict when it goes together with other conditions. You remember the democracy in mountainous terrain, democracy and the weak, strong economy combinations, right? And this is the key difference. This is the key difference between conflict prediction and kiwi fruit prediction. Kiwi fruit prediction, you look at a single kind of factor, you're good. Conflict prediction, no. You need information and real data about all sorts of different combinations. This is what makes this so difficult. Yeah, we can even map this out. This is basically a simple example of kiwi fruit prediction. If you say, okay, we assume that all these conditions are sort of independent from each other, we need a minimum. If we have n possible conditions, we need to take into account for kiwi fruit prediction 3, color of the kiwi fruit, shape, or weight of the kiwi fruit, right? And we make a prediction about the quality. Then we need to examine at least n+1 kiwi fruit, right? So this is sort of the data demand is linear in the number of the conditions we look at. This is sort of, some of you may be familiar, political scientists, with the Nils method of difference. This is Nils method of difference, sort of, right? If a kiwi fruit is bright, oval, and heavy, quality is good. Yeah. And now all the 3 remaining ones, they just change one of these conditions, right? You keep those 2 constant, the others constant. And here you change the second one. For the 4th one, you change the last one, right? And this is the outcome you get in terms of quality. Yeah. And here, you know, okay, the quality remains good, but the difference between this one and this one here, the similar feature between this one, the first one here, and the second one is, sorry, I'm getting lost. We're looking at sort of a combination of conditions where different ones just make a difference. If you replace this one here and this one, the quality prediction changes to poor, whereas here it remains the same. And say, okay, great. So it must be sort of the weight feature that that you're taking into account, right? Or oval and weight is sort of are the ones that. No, I'm not explaining it well. I'm sorry. Right. No, we need to look at this the other way around. We're predicting poor kiwi fruit quality, right? And if you see, okay, only in those cases where the kiwi fruit is bright, right, then the quality is poor. So no, this could also doesn't make sense. Well, all right, I'm sorry, we can come back to this, but the overall thing I want to illustrate here with this simple example is that with the conditions for kiwi fruit prediction are independent from each other, the number of instances you need to examine is limited, right? It's very limited. It's linear, sort of in the number of conditions you're looking at, right? For n possible factors, yeah, if the predictive pattern now, we're trying to the predictive pattern for conflict, right? If the predictive pattern for conflict, this is wrong here, this should be conflict. This is complex as we assume, right? And we have n potential factors. We need to look at least n potential cases. If we say, okay, for n possible predictive characteristics of a country, for example, and we say, okay, each of them needs to be present in the causal recipe. This means that each of them can be negated or not, right? If we assume that 15 factors matter for conflict predictions, we need 32,000 observations, roughly, right? And here you see that the data demand in order to be able to figure out what's going on for conflict grows exponentially, yeah? So this is the general problem. This is the general problem, this discrepancy of conflict and kiwi fruit prediction, one being very simple, conflict prediction being very difficult in a sense, because all of these conditions can be present, absent, they can matter or not. They can matter only in relation with others. Yeah. What is, now I'm turning to sort of the solutions we can find for this. We need a lot of data. This is what I wanted to show on the previous slide, right? And in practice, we really do not have that much data about conflicts happening worldwide, right? If the predictive pattern, if we want to do kiwi fruit prediction, and our predictive pattern is as simple as we assume, just one condition we need to look at and we're good, right? We don't really have to do much. We need a bunch of kiwi fruit, very limited number. We can train our classifier to detect what matters for kiwi fruit quality prediction, and we're good, yeah. If that is not the case, if our simple assumption was not correct, we can just grow more kiwi fruit and feed it through the machine. Yeah, that's super easy. Yeah, there's lots and lots and lots of kiwi fruit coming out of New Zealand every year. So we have potentially plenty of data available. That is not the case for conflict prediction, obviously, right? We don't want to grow conflicts, quite the opposite. Yeah. So here's a bunch of solutions that people have turned to also in political science. Solution one is to make the causal recipe for conflict as simple as the one for kiwi fruit, yeah, by assuming that your model is additive in the sense. Additive in a sense, as you know, this is sort of what happens with conventional regression models, right? Say a bunch of this and a bunch of that and a bunch of this together. Each of these factors increases the risk for conflict. But essentially, these models treat every single condition as independent from another, unless you insert a whole bunch of like interaction effects and this kind of things. But by default, this is what a regression model does. It chops up the complexity by saying, okay, now let's look at this factor, democracy, for example, in isolation. That's it. We are bracketing out everything. We're netting out the rest, right? This is what typical statistical models, and I think by typical, I mean the regression type of models that we do. We use this is what they assume. Yeah, they assume it's assumption that goes in that conflict prediction is similar to kiwi fruit prediction, right? In a probabilistic sense. I'm switching back and forth between a probabilistic and a Boolean type of world, but sort of overall, the idea is the same. The conflict risk, the regression model is the sum of several risk factors, and each of them contributes individually. A bunch of this, like a weak and young democracy, a weak economic performance, and mountainous terrain, they add up to a particularly dangerous or potentially dangerous situation, right? So here we constrain, in the notation that I introduced earlier, we constrain the space of potential predictive patterns by reducing them to length 1. Yeah, and each of them just adds a bunch more on our risk scale. Yeah. So these additive models may be useful for hypothesis testing. In hypothesis testing, we're interested in individual factors, right? We are interested in whether, for example, a young democracy has a higher risk of civil war, right? But as colleagues, for example, Mike Ward and others have shown, that these models perform really, really poorly for prediction. Yeah, and so you can get predicted values out of these models, right? It's the y hat you can generate, and then you can see, okay, how does it map onto the real outcome in a particular case? But this doesn't really work well. So 2010 paper in JPR, they cannot capture. Maybe this is not surprising because the reality is much more complex, where stuff depends on other stuff before it gets dangerous. Yeah. Right. So in other words, if we want to improve prediction, if we want to get prediction right, we need to have a good idea from the data what our pattern, our predictive pattern looks like. Yeah. Now we can throw in more complex models. This is where much of machine learning research goes. Yeah. Machine learning models, trees, rule-based system, forest, whatever, right? They are able to identify much more complex relationships where this matters in conjunction with this and a little bit of this, plus more of that. Yeah. This is perfectly feasible. Yeah. The problem is that we don't have the necessary data. Yeah. Conflict is, luckily overall, a relatively rare event. If you look at countries over time, only a small percentage actually experiences a civil war. So we just can't get the necessary information out of these data, right? We cannot grow more cases. We shouldn't be growing more conflict cases. Problem is we don't have it. We don't have more data about this. Yeah. Now, this is the third solution, and this is also what you see a lot in conflict research that's happening. We can predict with simpler patterns, right? Those that have been, here I don't mean assume them, but we can just say, okay, this, based on theory, focus on those patterns, those characteristics, phenomena that have a relatively short causal distance to political violence. Yeah. Mountainous terrain, the causal path between mountainous terrain and conflict is very long. A lot of stuff has to happen in between, which are all conditions you need to look at if you want to figure out if mountainous terrain has a predictive value. Yeah. But you could also say, well, I'm focusing on something that is already pretty close to political violence. Yeah. Short causal distance, mass protest, for example. We've seen a bunch of cases where mass protest escalated to civil war, right? The post-Arab Spring cases are cases in point for this. Yeah. So this causal distance is going to predict relatively well, because you're looking at a phenomenon as a predictor, mass protest, that's relatively close causally to the outcome you're interested in, full-fledged civil war. Yeah, this works well for prediction, but then sort of you get into a fight with the explanatory part of political science, because they say, oh, well, yeah, that's kind of, we figured that much already, because mass protest is collectively mobilized population, right? It doesn't take much for mass protest, large scale and potentially violent mass protest, to escalate to what we call civil war. Yeah, there's a short causal distance. That's maybe less informative. Should we be doing this? is this telling us a lot from political science point of view? Yeah. In reality, however, I've simplified this prediction world a lot already. Like, as many of you can imagine, in the real world, this type of prediction is much, much more difficult. We're not looking at binary yes, no conditions, young democracy, yes, no. In reality, our predictor variables are continuous. Yeah, we don't know what a young democracy is. We don't know what a full democracy is. I mean, right? You can arbitrarily assume a cutoff on the polity scale, but in reality, you don't know if a cutoff at level of 6 is good for conflict prediction. You could learn this from the data, but then you have to try sort of lots of different things. Your functional form that maps a predictor onto the outcome becomes much more complex rather than a yes, no kind of thing. Yeah. Right, we cannot vary the combinations of factors we examine. Oftentimes we would be interested for one particular condition if it works in conjunction with another. In order to find out, we have to vary this other condition to look at basically all different combinations. We cannot really do this. We are presented with a set of empirical cases, full stop. That's what we have to work with, right? Fortunately, we cannot grow conflict. We should not be growing conflict anywhere for the sake of scientific progress here. Yeah. But from a predictive point of view, that makes the task more difficult. Yeah. Maybe we can also wait for a combination of factors to emerge in order to be able to say, okay, this is a particularly dangerous condition. Yeah. Also, there's likely to be much more than one predictive pattern. There's different sequences of capital letters in my notation that lead to conflict. Yeah. And this makes the search even more problematic. You're not just looking for this one single predictive pattern that predicts a civil war. Yeah. And that's it's a huge problem here. Yeah. Many factors, also another difficult condition. Many of the factors that predict conflict are very difficult to measure. Measurement in political science is a sort of can be very, very difficult, right? Because we're looking at stuff that is not readily available in the news or anywhere else, whatever our data source is. So it's very difficult to observe some of the factors that we think contribute to conflict prediction. Yeah. So all of this gets much, much more complex. In conclusion, I'm out of time, yeah, and I think you share my, hope you share my first conclusion here that conflict prediction is challenging and it remains so in the future. And I'm saying this like independently of the progress we're making with much, much more complex and sophisticated prediction models, right? My point is that even if you throw these complex models, the data that we have about conflict, the conflicts that occur in reality, we cannot figure out what's going on, regardless of how flexible and powerful these classifiers are, right? We just don't know. We don't have the full set of conditions present. Yeah. And so my prediction, if I may, will be that these more complex models that we throw at the data will only improve forecasts marginally. And I'm hoping this may upset my friend and colleague Howard Hager at Uppsala, who has been engaging in a big project on conflict prediction. But I'm not sure. I think he shares my conclusion that the improvement of the forecasts he has been making in this big conflict prediction project funded by the EU, hundreds of millions of euros, just doing conflict prediction, only marginal improvements, right? Even if we put in a lot of very, very powerful and sophisticated prediction machinery. Yeah. Right. So this one here, what we could do is what I've showed before, is that we focus on short causal recipes, on antecedents of conflict that are relatively close causally, yeah, that are very close, stuff that's almost a civil war. Yeah. That may be a good predictor. It may be useful to look at mass protests and to identify those cases that will eventually potentially erupt to civil war. But the problem is that this gets you in trouble with the explanatory political scientists who are interested in explaining, because that's not so interesting from an explanatory point of view. So overall, big dilemma. Yeah, it's difficult to see how much progress we can make in this particular and very important task of identifying countries and conditions that make civil war more likely in order to prevent this particular phenomenon. All right, I'll stop here, and I'm looking forward to your questions.
Great. Thank you, Nils, so much. I will remind our participants, please submit any questions into the chat. We have a few lined up. I'm going to kick things off with perhaps a softball, but I always enjoy these ones. So every year we see a number of groups like the International Crisis Group and the Council for Foreign Relations put out a list of hotspots to look out for 2021 or places of high risk. I think you've already pointed to a number of things that we maybe should think about, but wondering if you could talk a little bit about what do you think about when you look at these kinds of predictions, and what are the kinds of things that we should be wary of when we include these in kind of our keeping up with the world?
Yeah, thanks very much for this question. I think this is a good one, and I think it depends on how these predictions on these lists are generated. Right? I know that some organizations, they have a bunch of experts working, or they work with a bunch of experts, and those experts know particular conditions really, really well, and they say, okay, in this country at this time, well, we have certain tensions arising, and it may be the case that we see civil war in the near future, right? Those are sort of expert-based assessments, and they're not derived from this general inductive way of dealing with data that I focused on here. What I focused on was this learning approach, right? Throw in a bunch of data, and then the computer develops an algorithm that's able to identify these dangerous combinations, right? I think expert prediction may be sort of similar to what I call this short causal distance, right? Because experts may issue a warning for a particular country, and in case they see that things are sort of getting very close to the point of being a civil war, right? That potentially is a short causal distance. Yeah? So this may be this is the third solution that I presented here. Yeah, in general, what do we need to know a little bit more about these lists. Overall, I think that they are the ones that are expert-based are overall pretty good because of this short causal distance. You're looking at combinations or phenomena or developments in the country that are already pretty close to civil war, right? Of course, that's an easy prediction task. So it's not a big, or shouldn't be a big surprise that you're predicting well. The others, I think the EU has a unit that sort of engages in this global conflict prediction. They even create an index. And here I think the performance is not as good. Yeah, probably for the reasons that I discussed here. But here I would be skeptical sort of our ability to predict conflict well, just given the fundamental limitations that I outlined, and that won't go away regardless, even if you ramp up model complexity massively. So I would be, overall, not surprisingly, I would be skeptical of these lists. Yeah, I would not base solid policy on this.